Hi there, Mr. Holcomb here with another episode of The Math Behind the Modules. Okay, lesson 9, perimeter and area of triangles in the Cartesian plane. Classwork opening exercise, find the area of the shaded region. So you have a region here with a portion cut out. They want you to find the area of the shaded green region, and in the circle, the purple. Pause the video because it's a classwork. See if you can do it, and then come back and see how you did. Alrighty, so here we go. Well, it's in the Cartesian coordinate plane, and it's going from 1 to 5. So this is a distance of 4. And it's going from -2 to 2. So that's a distance of 4. From here to here, 2 to 4, 4 minus 2 is 2. From here to here, -1 to 1 is a distance of 2. Those are the dimensions we need to solve this. So for starters, I want area of a square equals side squared. Okay, and area of a triangle equals 1/2 base times height. So you always write the formulas, substitute in the givens, and solve. So over here, the area of the square is going to be 4 squared, which is going to give us an area of 16 units. So if that triangle was not cut out of the center, the area of the shaded region, if this was shaded, would have been 16 units, but we need to subtract what they removed. So the area of a triangle is 1/2 the base, which is 2, times the height, which is 2. Okay, well, half of 2 times 2, or half of 2 is 1, and 1 times 2 is 2. So the area of the triangle is 2. Or you could say 2 times 2 is 4, and half of 4 is 2. So this is 2 units. So the shaded region, area of shaded, equals area of square minus the area of the triangle. So the area of the shaded region is going to be 16 minus 2, or 14 units. Okay, now let's do the circle. All right, the area of the region is a circle. So area of a circle equals pi r squared. And the area of a rectangle equals base times height. So the area of our circle is going to equal pi. And what's the radius? Well, the radius is the distance from here over to here, which is 0 to 3, or 3 squared. The area of the rectangle is base, which is this. From -1 to 1 is 2. And from -2 to 2 is a distance of 4. I'll put it over here. This side here is 4. So the area of the rectangle is going to be base 2 times height 4. So the area of the circle is going to be 9 pi. The area of the rectangle is going to be 8. So the area of the shaded region is going to equal the area, it's going to equal the area of the circle minus the area of the rectangle, which is going to be 9 pi minus 8. So let's see. Let's use our calculator for this. Let's do an approximation. Because if we don't do an approximation, we're done. Can't combine a pi irrational number with a rational. So I'm going to say 9 pi minus 8 equals, and we're getting an approximation. So I'm going to put the approximate symbol, and it's 20.27. 20.27 units. Alrighty, hopefully you got those. So let's move on, extend the page, and let me clean this up and get this footer out of the way. Okay, so this is our first example in the lesson, and it says, consider a triangular region in the plane with a vertice of 0, 0. A is 5, 2, and the point B is at 3, 4. What is the perimeter of the triangular region? Okay, so if we are going to draw this, do we need to draw it? We don't. Let's just do it without a diagram. So to find the length of OA, so OA, the length of OA is going to equal, so distance is the square root, distance formula is the square root of x2 minus x1 squared plus y2 minus y1. Whoops, not y squared. Eraser little. Okay. y2 minus y1 squared. Okay. So this would be the distance. Distance equals the square root of the difference in the x's squared plus the difference in the y squared. It is actually the Pythagorean theorem. So OA is going to equal the square root of x2 is 5 minus 0, which is 5 squared, plus 2 minus 0 squared, which is 2. 2 minus 0 is 2. So the length of OA is going to equal the square root of 25 plus 4. So OA equals the square root of 29. Okay, so that's the length of one side. So it's looking for perimeter. So remember, perimeter is the sum of all the sides. So there's one. And now I'll just change colors for the next one. So I'm going to look for AB. The length of AB equals the square root of the x2 minus x1 quantity squared plus y2 minus y1 squared. So AB is going to equal, so now we're doing A and B, well, 3 minus 5 squared plus 4 minus 2 squared. So AB is going to equal negative 2 squared plus 2 squared. So AB is going to equal, well, negative 2 squared is 4, and 2 squared is 4, and 4 plus 4 is 8. So I'm just going to save a step here and just say, well, it's the square root of 8. Okay, so that's that. And finally, we want to find OB. The length of OB is going to equal the square root of x2 minus x1 quantity squared minus y2 minus y1, well, that's plus, squared. So the length of OB is going to equal the square root of, so we're looking at O and B this time. 3 minus 0 is 3 squared plus 4 minus 0 is 4 squared. So OB is going to equal the square root of 9 plus 16. So OB is going to equal the square root of 25. All righty, so now the perimeter equals the sum of all the sides. So it'll be the square root of 29 plus the square root of 8 plus the square root of 25, which is 5. So our perimeter is going to equal square root 29 plus square root 8 plus 5. And we're going to get an approximation of 13.21. So P is approximately 13.21 units. And since it is an approximation, since I approximated, I should have my approximation symbol. Okay, page 2 brings us to what is the area of the triangular region. So I brought in a diagram, a zoomed in on the coordinate plane where this is located. So O is at the origin, A is at the point over 5 up 2, and B is at the point right 3 up 4, as this states right here. And we found OA to be the square root of 29. So I'm going to label this diagram. OA is the square root of 29. AB is the square root of 8, and OB was a length of 5. So there's the three things we know, but I can't find the area of that unless it is a right triangle and I take half the base times the height. So in order to do that, what we will do is we will drop a perpendicular onto this. So let's do it in red, and a perpendicular line coming down from a point, from the vertex down to a point that is perpendicular to its opposite side is called an altitude. So it's called dropping an altitude. So I just dropped an altitude. So now I just made this right triangle here. And I know that OB is 5. And I need to find the length of this here. And I'll put the letter P here. Okay. Okay, so when I drop this altitude here, the problem is I don't know the measure of this angle, angle BOA. I don't know the measure of angle OBP. I don't know the measure of BPA or AP, or I'm sorry, PAB. And I don't know the measure of angle ABP. I don't know any of those angle measures. All I know are these side lengths. I don't know what OP is. I don't know what PA is, but I know OA totally is, the total is square root of 29. But I can take this rectangle and create 3 right triangles and find the areas of each. So if I do that, here's what the process would be. Let's make it blue. And I'm going to look for the area of this triangle first. Let's do this one in blue. Okay, and so this distance here is 4, and this distance here from 4 to B is 3. So the area is 1/2. So area equals 1/2 base times height. So the area of this blue triangle is 1/2 3 times 4. So the area is, half of 4 is 2, 2 times 3 is 6. So the area of the triangle OB, and whatever point this is, if we named it, the blue triangle here is an area of 6. Now we're going to do the same. I will use green this time, and we will find the area of this. Oh, I'm sorry, not that. We're not doing that. The area of this triangle outside here. Okay, so if I make this triangle here, let me delete this line. Oops, the green one there, delete. And I'm not going to use this. Let's get rid of that. All right, so then now we're finding the area of this green triangle. So I will do this one in green. So area equals 1/2 base times height. So the area equals 1/2. And this distance from 3 to 5 is 2. And the distance from 2 to 4 is 2. So the base is 2 and the height's 2. So that'd be 2 times 2. Well, half of 2 is 1. 1 times 2 is 2. So the area of the green triangle is 2. I'll do the last one in red. So I'll highlight this triangle with my red pen. Okay, so it's this triangle here. It is a right triangle. So I can do 1/2 base times height. So area equals 1/2 base times height. So the area equals 1/2. My base is 5. And my height is from 0 to 2 is 2. Okay, so half of 2 is 1. And 1 times 5 is 5. So the area of the 3 triangles needs to be subtracted from the area of the rectangle. And the area of the rectangle is just simply base times height. So the area equals, or length times width, 5 times 4. So the area of the rectangle is 20. So the area of the triangle inside here, triangle, I'll name it ABO, triangle ABO equals, area of triangle ABO equals the area of the rectangle minus the areas of the 3 triangles that are outside here, because the total for the four triangles total the area of the rectangle. So the area is going to be 20 minus 6, which is 14, minus 2 is 12, minus 5 is 7 units squared. Okay? Okay, so here's where this lesson gets very challenging. So just bear with me. It says find the general formula for the area of the triangle with vertices 0, 0, which is here. A, x sub 1, y sub 1, so that's A, and B is at the point x sub 2, y sub 2. Okay, so that's what they're naming these, just simply because they did A first. So over to x sub 1 up to y sub 1 is 0.1. Over to x sub 2 up to y sub 2 is 0.2 or B. So this is 0.1, this is 0.2, and the origin. Okay, so first thing we're going to do is find the area of those three triangles with respect to the names of the sides. So for starters, let me color code it again. The left side we will do in blue. So we're talking about this triangle right here in general. Okay, so let's first put the triangle there. Okay, that's good enough. And let's use blue for that triangle. So what is the area of this triangle? Well, area of a triangle equals 1/2 its base times its height. And the base is a length. It's this here. It's from 0 to x sub 2. So it's x2 times y2, 0 to y2. So that is a length of y2. Okay, so there's the area of the blue triangle, 1/2 x sub 2 comma y sub 2. Now I'm going to do the same with the next one. I'll do that one in red, and that is this triangle here. Okay, let me just move this a little bit like so, and I'll do this in red. So the area equals 1/2 the base. Well, what is my base? Let's call this the base. It's x sub 1 minus x sub 2. That's the length from point B over to here. X sub 1 minus x sub 2 times the height, which is y sub 2 minus y sub 1. Hopefully you understand that. If this was 3 and this was 2, 3 minus 2 equals 1. That'd be a length of 1. So y sub 2 minus y sub 1 tells you how long a vertical segment is. X sub 2 minus x sub 1 tells you how long a horizontal segment is. And in this case, it's x sub 1 minus x sub 2. We're going from big to small. All right, so then finally we'll do the next one in green. So when I do this last one in green, like so, it is going to be this triangle here and like that. Let me just fix this last line here, the side. All right, so there it is. And so doing that in green, well, the length of this is x sub 1 minus 0, or simply x sub 1. So the area, so actually let me move this over here. Let's put them all on the same side. Okay, and now I'll do this one in green. The area of the green triangle equals 1/2 the base, x sub 1 minus 0, or simply x sub 1, times the height, y sub 1 minus 0, or simply y sub 1. The area of the rectangle I'll put over here. The area of the rectangle is the length x sub 1 minus 0, or x sub 1, times the base times the height, y sub 2 minus 0, or y sub 2. And I don't need that dot. Let's get away from that dot and just write x sub 1, y sub 2. Okay? All right, so there's the area of the square, area of the blue triangle, area of the red triangle, area of the green. So what we're going to do is say that the area of the rectangle minus these three triangles will be the area of that white triangle in the middle. So the next thing we're going to do is write the area of the rectangle, x1, y2, minus this one, 1/2 x2. There should not be a comma there, it's times. 1/2 base times height. Okay, no comma. 1/2 x2, y2. Okay, so I'm taking the full rectangle minus this triangle minus this triangle, which is 1/2 x sub 1 minus x sub 2 times y sub 2 minus y sub 1. And then finally minus the green one, which is 1/2 x1, y1. Alrighty, so there's the formula. It's pretty messy looking. Color coding hopefully helps you see it better. And the next thing I'm going to do is I'm going to show you what are like terms. So I will use my highlighter to do that. I will just use yellow. So I'm looking for like terms. So I have x sub 2, y sub 2 here. And I have an x sub 1, y sub 1. Okay, so what I need to do is I need to expand this first. I didn't do that yet. So let's do that first. Let's go back to my pen and let's just do it in expansion form. And what does that mean? Well, distribute. So x sub 1, y sub 2 doesn't change. Minus. But now I'm going to distribute this 1/2. I'm going to do this. Okay, so that's going to be 1/2 x2, but I can't distribute here because there's no plus or minus. So think of this one as just simply 1/2 and then x2, y2. It's all multiplied together, so it doesn't have anything here. But when I get to these binomials, then you need to distribute, so be careful there. And then the red one is going to be minus 1/2 times x. So a negative times a positive is negative 1/2 x sub 1. A negative times a positive is positive 1/2 times x sub 2. Okay, hopefully you're following this. And then it is going to be, let's see. 1 second here. Okay, I am going to erase this. Let's fix that right there. I knew I was off the rails. Okay, so I'm back. I was derailed. Now I'm back on the tracks. So what did I just do here? I distributed here, but right here, this would only be distributed to this at this point, but I need to FOIL this. So I'm just going to do that first, minus 1/2, and FOIL would be x sub 1. First term means first times first, so it would be x sub 1. So I'm going to put a parentheses here because it's 1/2 this whole thing. X sub 1 times y sub 2. There's F, FOIL. Outer, positive times a negative is negative. X sub 1 times y sub 1. Inner is minus times a positive, so it's negative. X sub 2 times y sub 2. Okay, so this is just basic foiling. And then negative times a negative is positive, x sub 2, y sub 1. And then it's finally going to be minus 1/2 x sub 1, y sub 1. I didn't close my parentheses on that term there. Okay, so now I'm going to distribute this half all the way through. So I'm going to take x sub 1, y sub 2, didn't change, minus 1/2 x2, y2, minus, now I'm multiplying this throughout distributing, minus times a positive is minus 1/2 x1, y2, minus times a minus is plus 1/2 x1, y1. Negative times a negative is positive 1/2 x2, y2. Minus times a positive is minus 1/2 x2, y1. And then finally minus 1/2 x1, y1. Okay, so I'm just expanding that red triangle was the one that was giving us the trouble because of the way we had to name it with side lengths with unknown points. Whew. Okay, hopefully you're still with me. So then what we do, if I'm going to just circle these things, I had to do this on paper first. It was so complex. I don't want to make a mistake. So now I have this. No, I don't. Let me just see if I made a mistake here. I rearranged first. So x sub 1, y sub 2, I have to find those like terms. So x sub 1, y sub 2 is here. I have an x sub 1, y sub 2 here. So those two are like terms. So I'm going to rewrite them together. X sub 1, y sub 2 minus 1/2 x sub 1, y sub 2. I can subtract those because they're like terms. So now I'm going to switch colors, and this time I'll use purple, actually blue. X sub 2, y sub 2. Do you see that anywhere? Here's an x sub 2, y sub 2. Here's an x sub 2, y sub 2. But notice their signs. This one is negative. This one is positive. They will cancel. Okay? All right. I have an x sub 1, y sub 2. I don't see another one. Okay. Oh, I already did that one. These two link together and are rewritten. So I don't want to make that mistake. And these two are already down here. These two canceled. I'm now looking at these. So I have a 1, 1. So let's use green this time. Here's an x sub 1, y sub 1, and here's an x sub 1, y sub 1. This is positive, this is negative, they're the same. That means they will cancel. Anything minus itself is 0, the additive inverses. Now I'm left with simply 1/2 x sub 2, y sub 1, and these two, which I've already done. This one here and this one here are right here. And now I'm going to just write minus 1/2 x sub 2, y sub 1. Okay. So then this is going to give me x sub 1, y sub 2 minus 1/2 x sub 1, y sub 2 will give me a positive, switch to black. That will give me a positive 1/2 x sub 1, y sub 2. And then we're going to have this minus 1/2 x sub 2, y sub 1. Okay, these are two terms. This is a binomial now. I have like terms. I have a half in each. x1 and x2 are different. y2, y1 are different, but I have halves in each. I will factor out that half. I'll use black for that. 1/2 times, and then I can just simply say x sub 1, y sub 2 minus x sub 2, y sub 1. And this is the general form for finding a triangle in the coordinate plane that's not a right triangle. So if I then knew values of these points like I do here in the last problem, 0, 0, 5, 2, 3, 4. So if I brought this down now, where is it? It's going behind. So let me move this to the front. Okay. So here is this point here. So, well, we have 1/2 x sub 1, y sub 2 minus x sub 2, y sub 1. What are these x sub 2, y sub 1 points? These are the 4 points. So if I look at this and label it, I can check this. So we have the point 0, 0. A is the point 5, 2. So x sub 1 is 5. Y sub 1 is 2. Whoops. Y sub 1, I'm saying is 2, so I wrote 2. and this is y sub 1. This is x sub 2, and this is y sub 2. So if I substitute this in, then let's check it. I take 1/2 x sub 1 times y sub 1 minus x sub 2 times y sub 2. All right, so this is going to be 1/2 10 minus 12. Did I do that right? No. I didn't substitute incorrectly. X sub 1, 5. Y sub 2 is 4. I'm sorry about that. It's a confusing concept. I don't want to make mistakes. I didn't substitute correctly. So substituting it in, x sub 1, 5. Y sub 2, 4. This will give me a different number, of course. Okay. X sub 2, 3 times y sub 1, which is 2. So it's going to be 1/2 of 20 minus 6. So 20 minus 6, 1/2 of 20 minus 6, that's in parentheses, so I should just leave it like this. I want to do what's in the parentheses first, follow order of operations, and then finish. So it's going to be 1/2, 20 minus 6, which is 14, and 1/2 of 14 is 7. And if we go back up to that prior problem, we got 7. How cool is that? Units squared. Ooh. 1/2 x sub 1 y sub 2 minus x sub 2 y sub 1. Any triangle in the coordinate plane will give us that, or will it? So that's the next thing we need to do. Okay, so now it says, does the formula work for this triangle? Well, what we need to do is, we are at the origin, by the way. So that is one thing that we have to have. We have to have a triangle where at least one of the points is the origin. So this is the point 0, 0, it's the O. If I call this A, sure, why not? And if I call this B, okay. So if A was x sub 1, comma, y sub 1, x sub 1, y sub 1, and this is x sub 2, y sub 2, then that should also work because this point here is at the origin. So the formula will work for this triangle. Okay. So I guess I should show that. Where did that come from? All right, so let's label these. Well, this would be, let me move these out of the way. A is x sub 1, y sub 1. So this is the point x sub 1. This is the point x sub 2. Right here. So this is a length of x sub 2. This is a length of x sub 1. This point right here is y1. This is the point x2. And so over x2, so this point, why did I put that there? I don't know. Let's get that out of there. Put this in palm. All right, so this is y1. This point up here is y2. Okay, and you could have done it rearranged. You could have called this x1, y1, and this x2, y2, like we did in the prior problem, but either way, it will work. Okay, we will get this. Okay, you all right? Recovered? All right, now we're going to put it to practice. Exercise, page 3, exercise. Find the area of the triangles with vertices listed. So here's one vertex, 0, 0, 5, 6, 4, 1. First by finding the area of the rectangle, enclosing the triangle, and subtracting the area of the surrounding triangles, then using the formula this. Okay. First by finding the area of the rectangle, enclosing it. So let me bring in a graph. Okay, so here we go. There is my graph. Let me just make a triangle. 0, 0. Come on. Okay, and there. Here's what the triangle would look like. Let me just fix this a little bit. Okay, there's the triangle. I'm not going to draw the rectangle. Hopefully you can picture that. The base of the rectangle, maybe I should. The base, oops, I forgot to do my straight line segment. The base of the rectangle is here, length 5. The height is going up to here, and then over, and then down. So that wasn't too bad, was it? So there's our rectangle, and there's the triangle inside. So it looks a little wonky here, so let me just, okay, anyhow, there is the triangle inside the rectangle. Okay. So let me see. Okay, I had to give that a little bit of thought here. This isn't a rectangle. That's a really weird shape. But if I do this, that is a square 1 by 1. So there's one unit I can avoid having to deal with. This is a length of 4, and this is a length of 1. This is 1. And from here to here is 6 minus 1, or 5. This side is, this diagonal here goes from 0 all the way up to 5. This length is 5. So the rectangle is 5 by 6. Say I put a 5 here. I'm actually doing that triangle here. Let's do the whole side first. So the rectangle is 5 by 6. 4 plus 1. And then this side, okay? So the rectangle is 6 times 5, or 30. So the area of the rectangle is 30. Okay? And then we have to find the area of this. So I'm just going to do this a little quick. I might not be showing all of my work. So just bear with me. Let me just do this one at a time. So let's do red or green. This is a length 4. I'm doing this triangle here. That's a height of 1. 1/2 of 4 times 1, or 1/2 of 4 is 2. So I'm going to subtract 2. Then this is a length of 1, and this is a length of 1, 2, 3, 4, 5. 5 times 1 is 5, times 1/2 is 2.5, or minus 2.5. And then this one is a length of 5 by 6. So 1/2 of 30 is 15. So the area of this figure should be 30 minus 2 is 28, minus 2 is 26, 25.5, 20.5, 10.5, if I did it correctly, 10 and 1/2 units should be the red triangle. Okay, I almost forgot. I didn't take the area of this square down here. 1 by 1 is 1. So let me fix that. So I forgot to subtract that little square in the corner. That little square in the corner is an area of 1 by 1, which is 1. So this will equal 9 and 1/2. So that's what we just did there. Now we're going to check it with this formula. So watch. So I do have one of the vertices at the origin. We need that. And we're going to take area equals 1/2. And we're using this formula right here. X sub 1 is right here, 5. Times y sub 2, which is over here, which is 1, minus, and this should all be in parentheses as well, minus x sub 2, which is here, 6, times y sub 1, I'm sorry, x sub 2 is 4, y sub 1, what am I doing? This is x sub 2 here, okay, and this is y sub 1. So x sub 2 is 4 times y sub 1, which is 6. So the area is going to equal 1/2, 5 times 1, minus 24. Is that right? X sub 1, 5. Y sub 2, 1. X sub 2, 6. Y sub 1, 6. X sub 2, 4. Y sub 1, 6. Okay. All right, so what's going to happen here is we're going to get area equals 1/2 of negative 19, which would be negative 9 1/2. So keep in mind, if we have to rearrange this to get a positive number, this should actually be absolute value. We will get the area, because area can't be negative. The area would be 9.5 square units. Okay, so we would have to have labeled those points counterclockwise in the graph. You have to go counterclockwise in order to get that to be positive every time. But if you can understand that area can't be negative and we're just taking the absolute value. So in all actuality, I would prefer that this formula be in the absolute value brackets, because you can't get a negative absolute value. You can't get a negative area. Okay. But we did get 9.5. If we were to have rearranged it and done it backwards, it would have been 24 minus 5, not 5 minus 24. And that would have given us 9.5 when we divided it by 2. Okay. All right, next problem. So let me clean this up and start fresh. Okay, in doing this, I might have labeled this backwards on the last one, but that's okay. Let's just move on. And I was more careful this time. Actually, this has to be moved to, whoops, here. Okay. All right, let's see. This should come over to B. Like so. There it is. So there's origin, the point 3, 2, and the point negative 2, 6 forms this triangle. We have 3 triangles here. So I'm just going to do this quickly. The area of the rectangle, this distance is 3 plus 2 or 5. The height goes from 0 to 6. That's a height of 6. 6 times 5 is 30. So the area of the rectangle is 30. And we're going to subtract all 3 areas of the square rectangles or triangles. So this one here is a distance of 2, and this is a distance of 6. 6 times 2 is 12. Half of 12 is 6. Minus this distance is 3. This distance is 2. 3 times 2 is 6. Half of 6 is 3. And from 2 up to 6 is a height of 4. And then negative 2 over to 3 is 5. Okay, so it's a 5 by 4, which is 20. Half of 20 is 10, so I subtract 10. So I'm taking away an area of 6, an area of 3, and an area of 10 from an area of 30 to get 30 minus 6, 24, minus 3, 21, minus 10 is 11 units. Okay. Now we're going to use this formula. 1/2 area equals 1/2. Okay, and it said, let's do it this time. Let's label it. Let's get this out of the way. Label it counterclockwise. So A is here, B is here. So if I do A first and then B, then this would be wrong. So I want to label B first. Counterclockwise. Yeah, I want to go this way. So A is x1, y1, and B is x2, y2, and we will substitute those values in. So 1/2 the quantity, x1, 3, times y2, 6, minus x2, negative 2, times y1, which is 2. So this is going to be 1/2 18 plus, because minus a negative. Negative 2 times 2 is -4, minus a negative is +4. 18 plus 4 is 22. So A equals 1/2 of 22, which equals 11 units. Okay, and it checked. Pretty neat. Okay, part C. Here's the diagram. 0, 0 is the origin, O. B is at the point -2, 6, which is right here. And A is 5, -3. All right, so the first thing I'm going to do is find the area of the whole thing. So if we're going from 5 to -2, that is a distance of 7. If we're going from 6 to -3, that is a distance of 9. So the area is going to equal 63, that's the rectangle, minus all of the pieces. So this is 2 by 3. So that's an area of 6, minus, this is going to be, now let me get rid of this 7 and this 9. We're not using those anymore. Now I'm doing this triangle here. So we already know the height's 3, and this is 1, 2, 3, 4, 5. 5 times 3 is 15. Half of 15 is 7.5. Minus, so this was 6. This is 7 1/2. I'll circle the areas. Side lengths are here. And then this is a length of 9. And this is a length of 7. So it's half of 9 times 7, or half of 63. And that is 31.5. So 31 1/2. 31 1/2 is this area here. This area here is 2, see the 2 there? 2 by 1, 2, 3, 4, 5, 6. 6 times 2 is 12, half of 12 is 6. So let's just make sure we have all of our pieces. This is an area of 6. 1, 2, 3, 4 areas that we need to subtract from the rectangle to get the leftover area. 1, 2, 3, 4. 7 and 31 is 38. And 1/2 and 1/2 is 1, so that's 39. 6 is 45, and another 6 is 51. So it's 63 minus 51, and that is going to equal 12 units squared. Okay, so now we're going to check it with our formula. So I'll write it so I don't have to keep going up here. So A equals 1/2 x1 y2 minus x2 y1. This will be, so if we're going counterclockwise, we want to name B first. So this is x1 y1, and this is x2 y2. Going, that's clockwise. What am I doing? All right, this is going to go here, and this is going to be x1, y1. Okay, counterclockwise. This one and then this one. All righty, so let's do this. A equals 1/2 x sub 1, 5, times y sub 2, 6, minus x sub 2, -2, times y sub 1, -3. Watch your signs. A equals 1/2, and 6 times 5 is 30. Negative times a negative is positive, so it's minus a positive 6. So area equals 1/2 of 24, and lo and behold, the area is 12 units. Units squared. And as you can see, it checks. So using this formula makes it a lot easier than graphing something and making all these different areas. We were just verifying that this works with every triangle that has a vertice at the origin. Whew. Okay, page 4 brings us to the end of lesson 9. Go to your problem set.